Sir, what question number is this?
This is question number 16, page number, sorry, question number 10, page number 7. Page 7, question number 10.
Okay, sir.
So we are not taking part A of this question because that is related to electricity. And in the starting part of the question, you can see it is mentioned water is plugged into a 230-volt main supply. So that is completely related to electricity. But from B part, we can relate with our topic. The specific heat capacity of the water is 4200 joules per kg degree Celsius. And the heater is used to increase the temperature of 6.3 kg of water. In a certain time, the temperature of water increases from 23 degree to 49 degree Celsius. Calculate the change in internal energy of the water. So value of C is given, right? And the value of temperature is also given. Mass is also given. And we need to find out the value of internal energy, or the amount of heat we can say in B part. So this is very simple to find out. We just need to use the formula, and that formula is Q is equals to M into C into delta T. Okay, what is your final answer after calculation?
Sir, can you scroll down? I'm solving it.
Sir, time is also not given in the question.
That is temperature. Delta T is temperature because T2, T1 is given. So mass is 6.3. Specific heat capacity is 4200. T2 minus T1, it means 49 minus 23. Six nine zero 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 zero. So you will get this type of answer.
Sir, I get 687960.
Okay.
Yes, sir, same.
Okay.
Same answer, sir.
Okay.
Yes, sir, same.
So we all are getting this answer 687960, right? And you can round it off. So it will be easy for you to write in your final answers. Like this is 8 and this is 7. So this 8 can be rounded off with the help of 7 and it becomes 6, 9. And we can just round it off to 0, 0, 0, 0. Or you can write your answer in this way. If you are writing the same answer 687960, so that is also fine. No issue. But
Sir,
yes,
you change it into the scientific
scientific notation.
equation. Yes, notation. So, sir, how did you get 690,000?
Okay. So first of all, when you want to convert, basically it happens when you got very lengthy answer. Like you are getting very lengthy answer. It is not in 100, it is not in 1000. So it is greater than it. So what we need to do, we just try to round off the values. Basically, we have 6, 8, 7. After 6, we have 8, right? And we know this 8 can be rounded off with the help of 7. So a 7 helps 8 to round it off to 9, right? So we make it 9. And rest of the values we can just round it off to 0, 0, 0, 0, 69, 690,000 joules. Okay. And
So,
if you
sir, if I, yeah.
Hmm. And if you are writing the original answer, so that is also fine, no issue. But if you are like converting into scientific notation, so like for that you need to write your answer in two figures or two significant figures like 6 and 9, and rest of the values are 0, 0, 0. So we can shift them into the power of 10. Okay.
Okay, sir. So, whenever we have like 6-digit answer, so we'll put the comma in between and forget the last three digit.
Yes. Yes. Basically, we are right now in grade 9. Okay. So it is not compulsory to round off for every like question, right? So we are trying to practice. So it is not compulsory because you have enough time to practice this idea. So one by one, when we practice on like daily basis, so it will be like very easy for you. So right now you can write your original answer 687960. You will get marks for it because you are not going to appear for board exam this year. Okay. But before the board exams, we like become used to of writing the answer in scientific notation. Okay. So that's why whenever we got this type of lengthy question, so I will let you know that how to convert or how we can round off this value into the scientific notation. Okay. But in your test, like in your class test or in a school exams, you can write your original answer. No issue.
So, sir, if after this we are getting 690,000, so shouldn't we be having 6.9 by 10 to the power of 4?
Okay, basically the value you are writing after decimal is also the part of the power in the exponent. Okay. So the value before decimal is not the part of the power, but all the digits after the decimal is also the part of the power, right? Or the value given in
Oh,
the
okay.
exponent.
Okay.
Like we
Okay,
can
sir.
also write in another way. For example, 6.87. This answer is also correct, right? Because we know after 87 and including 87, we have total 5 digits after 6, right? So that's why we used to say 6.87 into 10 to the power 5. But in your exams or like in O levels and A levels, they usually consider two significant figures. So one before decimal, one after decimal. So that is enough. So that's why you will get answers mostly like this.
Okay. So when even so we'll say just every single of we have, so we can put it into the scientific notation, right?
Yes.
Even if the answer is of 3 digits only.
But if you are getting answer in thousands or hundreds, so you can write it as it is. But when you are getting like 7 digits, 8 digits, 6 digits, so then try to convert into scientific notation. Okay.
Okay, but sir, in the final O levels or the A levels, we will be like have to give our every single answer in the scientific notation, right?
Yes, so it will be like better because they accept normal answer, but for safe side, we need to convert into two significant figures, because that is the pattern
Okay.
of the answers in O levels. Okay.
Okay. So, sir, we should like whenever we're like rounding it off, we should just consider the first three digits only.
Yes.
Okay. Thank you.
Okay, now try the second part. Any idea? Read second part of the question and try to answer.
No, sir, I have no idea.
Okay, so in the second part,
Sir, maybe
yeah,
from the kgs of water.
okay. So question is, the heater supplies thermal energy to the water at constant rate. It takes more time for the temperature of the water to increase from 49 to 75 and then from 23 to 49. So basically when the liquid reaches the temperature 49, so it takes more time to convert the temperature to 75. In both cases, the increase in the temperature is the same. Basically, the increase in temperature is same, that is 26. So this is also the difference of 26 degrees Celsius, and there is also a difference of 26 degrees Celsius. So difference of the temperature is same, but at different values of temperature, we are getting different time duration. So suggest why it takes more time for this temperature to increase from 49 to 75 degrees Celsius. So basically, whenever we start thermal, or when we try to transfer thermal energy to the liquid, so basically what happens, at the start, the amount of thermal energy is not very much, or we can say that at initial stage, liquid try to absorb maximum energy, right? But when the temperature of liquid starts to increase, so remember the concepts of emission. Now the temperature of liquid is getting higher as compared to the surrounding. So it also starts to share thermal energy to the surrounding. It also starts to transfer thermal energy to the surrounding. Because initially the temperature of liquid is low, 23, like closer to the room temperature. So that's why it will be easy for water to increase the temperature. But once the temperature of liquid starts to increase as compared to the surrounding temperature, so it also starts to transfer thermal energy into the surrounding. Okay. And when it starts the thermal energy, transferring thermal energy into the surrounding, so that is actually the loss of thermal energy. So water is actually losing thermal energy into the surrounding. That is not like beneficial for us, because our main purpose is to heat up the water, not surrounding. So this is the reason that at higher temperature, of water as compared to surrounding, water starts to lose thermal energy into the surrounding and increase in temperature for liquid takes more time, right? Any confusion?
No, sir.
Can you explain again?
No, sir.
Okay, idea is very simple. Whenever the temperature of body is greater as compared to the other body or as compared to the surrounding, just like heater. So the temperature of heater is always greater than the surrounding. So that's why heater transfers thermal energy into the surrounding, and that's why we use heater to like increase the temperature of our room, right? That means our surrounding. So whenever the temperature of body is getting higher and there is a large difference between the temperature. So you remember one thing, that there is a factor of conduction also, that the temperature difference also helps to transfer thermal energy very quickly, right? So when water reaches the temperature of 49, so 49 is not like a normal temperature, right? It only takes place in sunny season, in like very hot summer seasons in few countries, right? Not all over the world. So 49 degrees very high temperature as compared to normal room temperature. So that's why when water reaches this temperature, so this temperature is higher on average as compared to the surrounding. So water starts to transfer thermal energy into the surrounding. So basically it is losing its thermal energy into the surrounding. So that's why it has to take more energy, more heat from the source to again increase its temperature, right? Basically, it is increasing its temperature by gaining of thermal energy and then lose it into the surrounding. But after some time, again, it starts to increase its temperature with the help of thermal energy. So just because of the loss of heat into the surrounding, water takes more time to increase its temperature. Okay.
Meaning that the temperature increase or the boiling would be much faster. It would become much faster if the temperature is less,
Basically,
the
it is not
surrounding temperature is less.
when we are boiling up the water, so we always cover it, right? Why we are covering up the water? Because we know if we don't cover that water, so water it starts to convert into steam and it also transfers thermal energy into the surrounding. So that's why we always cover up the container during boiling or this type of cooking process, because it will take less time to increase the temperature when the container is completely covered. But when container is not covered, right? So when you provide thermal energy, and we know that in water, there is a convection process, and in gases, there is also a convection process. So heat it starts to move in upward direction. So from the container, heat it starts to move in upward direction, and we know after container, there is completely surrounding and atmosphere around it. So your heat is going to be transferred into your surrounding. So the heat absorbed by the liquid is also going to be transferred into atmosphere. And definitely when it transfer thermal energy into atmosphere, so its temperature decreases. And to increase the temperature, it has to like gain energy from heater again. So that's why it take more time to retain its temperature to the higher value, because it is also transferring thermal energy into the surrounding. So this is the simple concept.
Okay.
Because temperature or thermal energy is also like sharing with surrounding. We are not sharing with surrounding, but water is sharing that thermal energy to the surrounding because there is no seal container or there is no cover is placed on the container to cover up that water surface. So that's why when the temperature of water is greater, so definitely it starts to transfer thermal energy into surrounding, because this is very general idea that heat always transfers from hot body to cold body. So 49 degree is like hot enough as compared to our surrounding, because in our surrounding this is not normal temperature. So let's suppose if your surrounding temperature is 22 degrees Celsius, so you can see there is a very large difference between it. And definitely heat always transfers from 49 degrees Celsius to 22 degrees Celsius. And your surrounding is like unlimited, like there are unlimited molecules in your surrounding. So definitely water takes more time to gain thermal energy to increase its temperature to the specific value of 75, because it is continuously losing it also simultaneously. Okay, so this is
Um,
the idea.
okay. So sir, if the